Unit 2, we are going to learn about bonding elements. So in Unit 1, we talked about atoms and elements and how they are built. Now we're going to talk about, zoom out a little bit and say, how do we put elements together to make new compounds or new substances? Okay. The first topic is just types of chemical bonds. So by the end of this, you'll be able to describe the types of chemical bonds, including ionic, covalent, and metallic, explain the differences between these types of bonds, and identify the type of bond between two elements based on their location on the periodic table. Okay, so first we need to talk about, well, what is a chemical bond? Chemical bonds are a lasting attraction between atoms, ions, or molecules. It is a way for atoms to satisfy their octet rule. So remember, we talked about atoms really want to have 8 electrons in their valence shell, and in order to do that, they need to get those electrons from somewhere or give those electrons to something. And so that's what a chemical bond is. It is two atoms coming together, sometimes more atoms coming together to share or transfer their electrons to make a lasting attraction. The physical and chemical properties of the elements are actually different. So if I look at this as a pure substance, it will have different chemical and physical properties from the compound that it is bonded in. So for example, if I talk about hydrogen, hydrogen is a gas, it's highly flammable, it's lighter than air. If I bond that with another hydrogen and oxygen to make water, that has very, very different properties, even though there's hydrogen in it. Okay, so there are 3 types of bonds we're going to look at. We're going to look at ionic bonds, which is the transfer of electrons. So one atom takes the electrons from another atom. Covalent, which is the sharing of electrons, and metallic, which makes a sea of electrons. And remember, all of these actions, transfer, sharing, or the sea of electrons, is to satisfy that octet rule. So let's first look at ionic. So ionic compounds are between metals and nonmetals. The electrons are transferred. So if I'm looking over here at this picture, sodium has a positive charge because it has given its electron to a chlorine, which now has a negative charge. And we looked at that in ions. Okay, we looked at, well, if sodium loses an electron, it becomes a positive ion. If chlorine gains an electron, it becomes a negative ion. And what happens when sodium and chlorine are together is that transfer of electrons happen, and then the atoms are bonded because of an electrostatic attraction. Think about magnets. If I have a positive magnet and I have a negative magnet, they're going to attract to each other. And that's exactly what an ionic bond is. They're really attracted to each other because one is fully positive and one is fully negative. The physical properties of an ionic compound is that they're always solid at room temperature. They have a very, very high melting and boiling point. They're hard and brittle. They conduct electricity, okay, when melted or dissolved in water, and they're very soluble, meaning they can dissolve in water easily. All right, the next kind of bond we're going to talk about is a covalent bond. Covalent bonds are between nonmetals and nonmetals. They share their electrons. So if you think about our electronegativity, we talked about how on the periodic table, on this side of the periodic table is our nonmetals and our highly electronegative atoms. And so they don't want to give up their electrons. So when they come together, they end up sharing the electrons because they both want to satisfy their octet rule, but neither one wants to actually give away any electrons. Okay, physical properties of covalent compounds, they can be solid, liquid, or gas at room temperature. They have a very low melting point and boiling point, meaning they will melt quickly and they will boil quickly with very little energy added in. They cannot conduct electricity. They're usually considered insulators, which is the opposite of conducting. Okay, and they're insoluble in water, so they don't dissolve in water. A lot of times, covalent compounds are called molecules, and we're going to actually look at a specific type of molecule, which is a diatomic molecule. Okay, so diatomic molecules are still a covalent bond. They just act, they're just kind of special ones. There are certain elements, and the list of elements is down here. These elements do not like to be single atoms. They really want to be bonded, and so they will bond with atoms of their own kind, and they actually only exist in this form. So nitrogen, iodine, chlorine, oxygen, hydrogen, bromine, and fluorine, okay, they are all highly electronegative, except for hydrogen. But so the rest of them are very highly electronegative. So they really, really want those other electrons to meet their octet rule. So when they're in contact with each other, they will always kind of travel as a pair. These diatomic molecules, you need to memorize which ones are diatomic molecules. Okay, and a way to remember this is I never bring classwork home on Fridays. Darn it, this should say Fridays over here. That's looks like it's a typo in my slides. Okay, so I is iodine, never nitrogen, bring bromine, classwork, chlorine, home, hydrogen, on, oxygen, Fridays, fluorine. So these are the 7 diatomic molecules. And if to name them, it's the element name. So if I'm actually talking about oxygen, I'm always talking about O2. If I say fluorine, I'm actually talking about F2. Okay. Unless they're bonded in other elements. And then if I say fluorine, I'm just talking about one atom of fluorine. Okay, the last bond I'm going to talk about is metallic. We are not going to learn more about metallic beyond this slide. So you really just need to know that it's a sea of electrons. Okay, so it's all about metals. So think about iron and lead and aluminum, those metals that, I have aluminum foil. It's very, very bendy, and those are actually aluminum molecules bonded. Okay, so they can be in solid or liquid state, and it's a sea of electrons because metals they want to give away those electrons. And so what will end up happening if I have a lot of iron, so if I'm looking over here at this picture, if I have a lot of iron atoms together, they're going to just kind of like, meh, this can be your electron, it can be my electron, it doesn't really matter. They're just all going to the electrons are just going to kind of float through them as like a sea of electrons. Okay. And you can see that down here in this picture too. So the electrons just kind of free flow through all the positive nucleuses, and that's just because they're so loosely attached to the atom. So physical properties of metals that are metallic bonded. So they're strong, they're malleable, so you can bend them like aluminum foil. They're ductile, so like copper wiring. Copper can be stretched really, really thin, which you can make into wire. Okay, they conduct electricity, and they're typically very shiny, so they have a luster to them. So that is the 3 kind of bonds that we are going to talk about, and we will talk mostly about ionic and covalent throughout the rest of the unit.